Alright, so in this video we're going to do a little introduction to what is algebra and introduction to functions in algebra. I'm going to try to keep this as brief as possible, but it does have a lot of information kind of packed into a small time period. So make sure if you need to watch it again or if you need to look up some extra videos, please do that. What is algebra? Well, if you read and you look up some definitions of algebra, you'll see things like the mathematics of generalized and arithmetical operations, a branch of mathematics in which mathematical relations are explored by using letters or symbols to represent numbers, a branch of mathematics in which variables are substituted for unknown values to solve a particular problem. All of those things are good, and we will talk about how to use variables to substitute for things that we don't know. We will talk about exploring relations between two quantities. And you'll see that also on my next page here for our definition, the study of functional relationships between two quantities that are quantified by real numbers. Generalizing what we know about math to cover a wide range of real-life situations. So essentially what we're doing is we are representing ways of thinking in life with mathematical functions. And so what we are going to talk about in this particular course is we're going to go through linear functions, quadratic functions, and exponential functions. Those three functions are three big keys of Algebra 1. And that's why we're putting them in this Algebra 1 overview course. So in this particular presentation, in this video, you're going to see just some basic things about functions. And so we get some things, some definitions and some terminology out of the way. So when I'm talking about them in the other videos, you'll understand what I'm talking about. First of all, you're going to see in several of the videos that we talk about ordered pairs, about plotting points. And so what I'm going to do is I'm going to do a quick little snapshot here of these points. We're going to graph these on the coordinate plane. Now, when I talk about the coordinate plane, what I'm talking about is a graph, as many people call it, made up of two axes that are number lines, your x-axis and your y-axis. The thing you need to be careful of is technically the word graph is the actual picture that you draw on the coordinate plane, not the coordinate plane itself. But the other thing that you need to make sure you understand is these are number lines. So when I talk about the x-axis and the y-axis, or the horizontal axis and the vertical axis, I am talking about number lines that describe where I'm at. So when I see a coordinate pair has an x value and a y value that tells me a location. It's very similar to a GPS. When we start drawing lines and curves across the graph, we're not just drawing just one point, one GPS position, but we're also looking at how that position changes from one point to another. And that's when we start getting into these relationships between numbers and telling us how to find the next point. That's a function. So first of all, we're going to just do a little practice of graphing points or graphing ordered pairs. So -4, -8 means that I'm going to go to -4 for x, and then I'm going to go down here to -8 for y and put a point. That's the point, -4, -8. 3, 6, right to 3 for x, and then up to 6 for y. 0, 0, that's the origin, that's the middle. Notice every point that I do when I graph a point on the graph, I start at the origin. -1, 3, -1 for x, 3 for y. And then -6, 6, 5, -6 for x, and 5 for y. So these points across the graph are just a set of points that you see plotted on this graph. They don't mean anything really necessarily to me. They're just points. Now, what we're going to talk about here in a little bit is you can get points for a function by using what we call a table of values, where you plug in some x's and it tells you what the y's are. Those mean a little bit more to me because those actually are values that I found by plugging something in, doing some type of mathematical operation, and getting something out. So we call those our inputs and outputs typically. In general, in math, when we have inputs and outputs, like this particular set of pairs here, we call that a relation. A relation is a set of ordered pairs that have inputs and outputs. Typically, those are our x's and our y's. We use other words like domain to talk about the x values and range to talk about the y values. When you're telling somebody what the domain is, you're telling them what the x's are. When you're telling them the range, you're telling them what the y's are. And then so a set of ordered pairs is inputs and outputs that go through and connect together somehow. Give you an example of this. Could be something about, you go at lunch and you decide you're going to take a survey of your friends. So when you go at lunch to take this survey of your friends, you say, okay, how many minutes do you study for math? So we're going to have minutes of study. And what is your grade in math class? Now, if you do that, for some people, they're going to be kind of embarrassed, maybe. Some people are going to be real proud of themselves. But you get a set of minutes over here. Let's say somebody says, I studied for 30 minutes and I made an 80. And you got this other guy who says, I studied for 10 minutes and I've got a 92. That's usually the ones that you hate because they're making really good grades even though they don't study, right? And so then you have things like a person who says, I study 120 minutes. That's 2 hours. And I can barely make a 70. And, that happens too. We have a lot of people who study for a really long time and don't make a great grade. And then so you just go through and you've got a lot of these different values here. And then you go through and you can take these values and you can actually plot these points on a graph of inputs and outputs like we did with these points over here. What happens in mathematics is we start to look and try to see if there are patterns to this. Is there some type of relationship, which is very different than the word relation? Relation is a set of ordered pairs. They go together, but they're not necessarily related, as in they don't have a pattern that tells you, you do this to X, you get this other answer for Y. In this case, think about our example that we just used. You study for 30 minutes, you're going to get an 80. That doesn't always happen. You don't always have an exact, perfect relationship between the two. In the real world, that just doesn't happen. But when we can see exact relationships, or if we can see things that are close to relationships between the two numbers, we use what is called a function. And a function is basically a set of ordered pairs, just like a relation, but this time the input is unique. What that means, and I'm going to highlight this because this is kind of important here, each input has exactly one output. That means if you plug in 30 minutes of study, you are going to get an 80 for your grade. So that is what we mean when we find a relationship between the two and we find this functional relationship, an exact amount that tells me if you plug in this input, you're going to get this certain output. That's a function. What can happen a lot of times when we have a relation is we can have a set of pairs, ordered pairs of dots that go up across the graph like this, and I'm just making this one up as I go. And it doesn't seem that there is a really strict apparent function here. But then what we can do is say, well, hey, if I do draw a line down through the middle of these points, it fits pretty good. That's what we call a best fitting line. And there is a direct relationship of y equals something with x over here. We call that a function of x. Meaning if I plug in an x value, I'm going to get the corresponding y value here by doing some mathematics, some operations to x. And what we do is we study these different types of functions. We go through and we actually see what happens and how does that end up looking in an equation form, and how does it look on a graph, and how does it look when we're trying to solve things for this. And so that's going to be the three big keys that we look at for linear, quadratic, and exponential functions. We're going to learn how to write the functions, we're going to learn how to graph the functions, and we're going to learn how to solve those functions. So just some basics with functions as we go through. First of all, you need to be able to recognize what they look like. They have a very specific pattern to them. Each input has one output. So when you talk about like a table, or in this case, a mapping diagram, and you see that this input right here has two different outputs, that right there is not a function. Guys, that's not normal. That's like me taking the materials to make a Mustang and putting it in the assembly line at Ford Motor Company for a Mustang and getting a Ford Focus sometimes. That doesn't happen. That's not a function. It is okay if I have an input here and an input here that both have the same output. That just means that those two x values have the same y value. Let's think about that in a physical way. This would be a function still because each input has only one output, even though some of them share the same number. Think about this in a physical way. We're going to talk about this a little bit later. You could have a shape that looks like this. Somebody could punt a football through the air. It leaves their foot and goes and lands. Right here and right here is going to be the same y value, even though those are two different x values here and here. So that's okay. That's still a function. So functions, each input has one output. It has this very strict kind of pattern to it. The next thing that you need to recognize and know about functions is that they can be lines or curves. Functions can have straight lines. Linear functions is what we're going to look at with those, or they could have curves, like something like this we're going to look at, or even something that has sort of a curve like this. It's kind of funky looking, but that is still a function because each input has only one output. You're not going to see things like this, even though this is normal, it's a circle. That's not a function because each x value or each input could have more than one y value at the same x value. That's not a function. So that causes some really weird things when we start dealing with equations for circles and things like that. You get a curve that looks like this. Guys, you can tell those things are not going to be something where it's really a normal situation. You don't go this way and then all of a sudden cut back and then go back this way again. That's going to be things that are not functions. But relations, yes, they still are a set of ordered pairs. They're just not a function. So functions can be lines or curves. Notice when I have lines or curves, when we think about the x values and the y values, when I have a line, that x value and that y value continues forever. That means it's going to touch all the x's and all the y's. That's going to change when I'm talking about things like the domain and range. But if I do just a small line segment, that's going to have a starting point and an ending point. That's going to change the domain and the range, or the x's and the y's that I use. So there are some things in life where you may use the entire equation, the entire line. There's some things in life where you may only use it for a portion of your time, but you still need to understand how to think in that format, in a function. A couple of other things that you need about functions. You'll see this symbol a couple times in class this course. This symbol is read as f of x. That's how you say it. It's the value of a function at a specific value of x. But it's just kind of a fancy way to write y equals. Like if I had f of x equals 2x plus 4, that's the same thing as y equals 2x plus 4. So when I say f of negative 2, that means plug in -2 for x. This is called evaluating a function. This is some kind of skill you're going to need to have for this class, of course, but you're going to need this skill in a lot of different jobs in life, where you just plug in a number for something, some kind of function, some kind of equation. You may not even call it a function or an equation. This may be some type of step-by-step process, which is what this is. You do 2 times -2 is -4, plus 4, that's 0. So when I plug in -2, I get nothing. I get 0. Guys, that's going to be something that you use in a lot of different jobs, where you plug in something that you know and you do the steps, do the math. Even if it's not math, do the steps in a job somewhere, and you get some type of output. You've got an input and an output. Notice, if I plugged in -2 again, I'd still get 0. If I plugged in -2 again, I'd still get 0. That's the whole idea behind the function, saying each input only has one output. So don't get bogged down too much by this. So the last thing I want to talk about with functions is the fact that we can represent functions with these equations like you just saw, y equals 2x minus 7, or f of x equals 2x minus 7. We're going to study what those different equations look like when they're linear, when they're quadratic, when they're exponential. I'm not going to be able to give you every single type of example possible in this course, but I will be able to go through and try to give you some of the major things. And part of your last final kind of project for this class is going to be you trying to show people and distinguish for people the differences between linear, quadratic, and exponential, and the similarities. Well, one thing that's a similarity for every function out there is that if you have this equation, you have the output in terms of the input, means you do something to the input, 2 times x minus 7, to get the output, the y's. And it gives you ordered pairs, like we talked about graphing earlier. It gives you x's and y's that go together. Like I said, if there was a function for that particular example of the studying in math grade, you would give the study, you'd plug in the study, and you'd get the output, which would be the grade. That ordered pair is a solution to the equation if it makes it work. And so one of the things that we'll also talk about in this course is how to solve equations. And what you have at the bottom of this page here, a note is that says a graph of an equation in 2 variables is the collection of all the points whose coordinates are solutions. That's a big, convoluted sentence maybe in your head, but what that means is, guys, we're going to learn how to graph these functions, not just know what the equation looks like. And the graphs are going to help us know what some solutions are. And then we're going to use other methods also of finding solutions. So graphing is not going to be our only method. We're going to have several different ways. We're going to make sure that we have a way to be efficient in several different aspects there. So that is what we are going to be taking a look at in this course. You're going to see that we're going to take something even in words and transfer it into something like an equation. Like Joe starts a summer job cutting lawns. He plans to charge $20 a lawn. So the money that he makes would be equal to $20 times the number of lawns that he cuts. This is a function, because if you plug in 10 lawns, you're going to get $200. If you plug in 10 again, you're going to get 200 again. So what we're going to be doing is learning how to use this concept of making a table of values, plugging in things like 0, 1, 2, 3, and 4. 0 lawns, he makes $0. 1 lawn, he makes $20. 2 lawns, he makes $40. Because I'm plugging that in and doing the math, because that's what a function does. A function has some type of relationship that it tells me his money is going to be $20 times the number of lawns that he cuts. And then we're going to take that and we're going to make a graph with it. So we've got, a little blitz review here of what functions are in this video. And as we go through this course, we're going to focus in on how do those things represent real life situations how do we, just study them mathematically? And how do we combine those two, the real life and the mathematics together?